Today's objective is dividing rational numbers, specifically fractions. So, here's an interesting fact. Dividing by a number is the same as multiplying by that number's reciprocal. Now, a reciprocal, this is review, should be review for you, okay? So a reciprocal is the number you multiply another number by to get 1, positive 1. So if I have the number 3/4, the reciprocal would be 4/3. Oh my gosh, look what I did. I added them. Because if you multiply them, you get 12 over 12, which is the same as 1. That was pretty funny, huh? If you have the number 3, now you need to remember we can always write a whole number as a fraction by putting 3 over 1. Well, 3 over 1, the reciprocal would be 1 over 3. It's the number inverted. Remember inverse? It's inverted. When you multiply these, you get 3 over 3, which is 1. So the reciprocal of 3 is 1/3. If I have negative 1/8, the reciprocal would be negative 8 over 1. If my number is a negative, the reciprocal is also a negative, because when I multiply, negative times negative is positive. So this would be 8 over 8, which is 1. Okay? That's just a little review on reciprocals. So here's our example. 8 divided by 2 equals 4. You know that. All right? Think, what is the reciprocal of 2? Well, if I made this be 2 over 1, if you flip that upside down, you would tell me 1/2. So now I can multiply the number by, instead of dividing by 2, I can multiply with the reciprocal of the 2. So I can multiply by 1/2. Now remember, when we're multiplying with fractions, I have a whole number, I can put this over 1. Then I check and see, do I have anything in common? Factors, yep. 2 goes into itself once. 2 goes into 8 4 times. 4 times 1 is 4. And I have the same answer. So dividing by 2, this is an example to show you dividing by 2 is the same as multiplying by 1/2. That's what I wrote right here. So we mainly use this when we are dividing with fractions, because multiplying with fractions is pretty easy to do. So here are some examples of dividing with fractions. So here I have my problem, 7/15 divided by 4/5. Now I'm going to multiply by the reciprocal of 4/5. Sometimes students make mistakes on this, and they do the reciprocal or flip the first number. It's what you're dividing by, your divisor, okay? So 7/15 times 5/4, the reciprocal. Now I see, can I simplify anything? Yep. 5 and 15 have a common factor. Let me get this pin right. Have a common factor of 5. 5 goes into itself once. 5 goes into 15 3 times. Now remember from the other video, when we're multiplying with fractions, we simplify and we multiply straight across. So 7 times 1 is 7, and 3 times 4 is 12. Here's another problem. 5/12 divided by negative 1/2. So instead of dividing by the negative, we're going to multiply by that reciprocal. Well, we're still dividing by negative 1/2. We're going to multiply by the reciprocal of negative 1/2. It still is a negative. I don't want you to think that. So 5/12 times negative 2 over 1. Now remember, the first thing you do is check, is my answer going to be positive or negative? Negative. So I'm going to put equals negative. Now I'll see if I can simplify anything. Yes, 2 and 12 share a common factor of 2. 2 goes into 12 6 times. 2 goes into itself once. Now multiply straight across. 5 times 1 is 5. 6 times 1 is 6. So my answer is negative 5/6. Well, what if I have a mixed number? Whenever you're multiplying or dividing with fractions, it's really much easier to change your mixed number into an improper fraction. So 3 times 5 is 15 plus 1 is 16. So this problem is the same as this problem. 16/3 divided by 4. Remember, any whole number can be made into a fraction by putting it over 1. So now instead of dividing by 4, I'm going to multiply by the reciprocal. So 16/3 times 1/4. They're both positive, so I don't have to worry about that. So I'm just going to say equals, and then I'm going to say, oh, common factor. 4 goes into itself once. 4 goes into 16 4 times. Now the reason I do this is because it's easier to multiply smaller numbers. I'll make less mistakes. And then at the end I don't have to simplify, because the bigger the numbers are, the more likely you are to make a mistake, and I don't want you to make a mistake. So 4 times 1 is 4, and 3 times 1 is 3. And since we had a mixed number to begin with in our problem, I am going to convert this one back to say this equals 1 1/3. Okay, if they were both fractions, I wouldn't bother, but since a mixed number was in the problem, it's appropriate to have a mixed number answer. Here's one more. Negative 3 1/8 divided by 5. Change my mixed number to an improper fraction. I put down the negative sign, and then I say 3 times 8 is 24 plus 1 is 25. So now my problem is 25/8 divided by 5. I'll make this be 5 over 1 and do the reciprocal of 5 over 1, which is 1/2. Now my problem is negative 25/8 times 1/5. Did I say half? Don't remember if I said something wrong. All right, I'll repeat what the real problem is. Negative 25/8 times 1/5. Now I look at my problem and I see that there's a negative in it. So if the signs are different, my answer is going to be negative, so I'm going to write that down first. Then I see, hey, 5 goes into 25. Isn't that nice how all these numbers can be simplified? 5 goes into itself once, 5 goes into 25 5 times. Now multiply straight across, and I don't have to worry about the negatives now because I've already determined my answer is going to be negative. So 5 times 1 is 5, and 8 times 1 is 8. So my answer is negative 5/8. And because that's a fraction, I don't have to worry about changing it to improper. Now sometimes you'll have word problems. So here's a word problem. The school stage is 8 3/4 feet wide. You have some large crates to put on the stage. Each crate is 1 5/12 feet wide. How many crates can fit on the stage? What are you being asked? Well, you could always draw a picture. You could say, here's my stage, and I have to put these large crates on it. So I need to see how many crates will fit on the stage. So how many times will the crate size go on to the stage size? So your question in math is, what is the stage size divided by the crate size? 8 3/4 divided by 1 5/12. So first I'm going to change these to be improper, then I'm going to use the reciprocal. And what's really nice is word problems, usually they don't have negatives in them. So 4 times 8 is 32. 32 plus 3 is 35. Come on, pen. 35/4 divided by 12 times 1 is 12 plus 5 is 17. 17/12. Okay, notice I write the problem as a division problem, then I rewrite it with the reciprocal. 35/4 times 12/17. Wow, wouldn't it have been nice if it would have been 32, 33, 34. Wouldn't it have been nice if this was 34, because 17 times 2 is 34, and then it would have gone into that. But it doesn't. But 4 does go into 12. 4 goes into itself once, and 4 goes into 12 3 times. So now I have to multiply 3 times 35. So let's do mental math, okay? 3 times 30 is 90. 3 times 5 is 15. What's 90 plus 15? 105/17. Now I need to change that back. Oh, I don't know how many times that goes in. I know that 17 times 5 is 85. Well, if this was, what's 17 times 7? Let's try it. 17 times 7, 9, 4. No, it's going to be too big because that's 11. So 17 times 6. So it'll be 6. Let me erase this so it's not so messy. So it'll be 6. And what's 17 times 6? 2, 4, 6, 102. 6 3/17. So the answer is 6 3/17. But do we have partial crates? No. So the answer is 6 crates, and we'll have a little bit of space left over, 3/17 of an inch, or feet, 3/17 of a feet. All right, so word problems really aren't that bad. I know this was a little bit messy. The biggest problem with word problems is just figuring out what they're doing. That's it.